All right, so we're going to finish up by getting into surface area, which is a little bit different than we did volume previously, so now we're going to talk about surface area for 3D shapes. Now there's two different types of surface area when it comes to three-dimensional shapes. There's something called lateral surface area, or LSA for short. That's the area of only the sides of a three-dimensional figure, so not the area of the bases. Total surface area, or TSA, is when you do the area of all the sides and the area of the bases. So there may be times that they say only find the lateral surface area, and they just want to know what's the area of just the sides that make up the shape. So I've created another chart in your guys' packets there that have the two different types of formulas for surface area for the shapes that we've been talking about. So again, prisms and cylinders, just like with volume, are going to share the same formula for surface area. Same with cones and pyramids, and then spheres have their own. Now, spheres also don't have lateral surface area. They only have total surface area, because spheres don't have sides like rectangles. It's just one continuously curved surface. So there's not going to be multiple sides or multiple like bases and faces that you're looking at on a sphere. Okay, so again, I've got the two separate formulas here, so just make sure you read the problem and you know like which one they want you to use. And then if you forget what some of those letters stand for, they're talking about those over here on the far right side. They kind of give you what P stands for, what H stands for, and that kind of stuff. So let's do some examples. So if you guys go to the next page there, we're going to start by finding just the lateral surface area of this prism. So lateral surface area, LSA. If I go onto that chart, just what we were looking at before, it's P times H. Now P stands for the perimeter of your base shape. So for a prism, especially a rectangular prism, I said yesterday that prisms are named based off of their bases. So yesterday we saw a triangular prism, and that meant that the triangles were your bases. For a rectangular prism, all the sides are rectangles. So it's a little hard to decide like which side is the base. So what I normally kind of recommend or say to students is the base on a prism like this is the side that it's like sitting on. So the bottom of this pyramid or prism, the 24 by 12, that rectangle on the bottom would be called the base. So to find the perimeter of a rectangle, remember you do 2 times the length plus 2 times the width of that rectangle. So we're using that 24 and 12. So we're going to do 2 times 24 and then 2 times 12. So that would be 48 plus 24, which is going to be 72, and that's for your P portion. Now, H represents the height of the prism. So the height of the prism is the distance between your bases. So that's going to be the 20 inches on this figure. So now I'm going to take this 72 and this 20, I'm going to plug them into that equation up above so that I actually can find the lateral surface area here. So we're going to take 72 times 20. And that's going to be 1,440. Now we're back to area. So when you label these, it's going to be inches or centimeters or whatever squared. Okay, let's take a look at the next one. Next one here says, how many square centimeters of sheet metal are required to manufacture a can that has a radius of 4.5 centimeters and a height of 9 centimeters? Assume that there's no waste and no overlap. So they want to know how much total is needed to make this whole can. So that includes the side and it includes the top and the bottom of the can. So for this one, we want to use our total surface area. So total surface area for this would be a cylinder is PH plus 2B. Now P still refers to perimeter of the base, but what shape is a base on a cylinder? circle. So really we're finding circumference. Okay, so for P we're finding the circumference of the circle. And then capital B refers to area of the base shape, so we're going to have to find the area of that circle as well. And then H is the height of this can. So what's the space between those two circles? All right, so let's talk about P, or in this case, circumference for a circle. Now remember, a circle you can do pi times diameter, or you can do 2 times pi times the radius. What measurement are they giving you for the circle? Radius or diameter? Radius. That 4.5 is just the radius. So I'm going to use the 2 pi r. So 2 pi times radius, which is 4.5. So 2 times pi times 4.5 is going to be, if I round it, 28.3. Now, what would be the height of the cylinder? Good, the 9 centimeters is your height. Now let's talk about capital B. Capital B is the area of the base, which we've already established as a circle. What's the equation for area of a circle again? Pi r squared. So pi, and we said that that 4.5 is the radius, so we're going to do pi times 4.5 squared. Which again, if I round, is going to be 63.6. So now I have all the small pieces that I need that make up this formula. So when you guys are doing volume, surface area, and like lateral, both total surface area, I would suggest breaking it down into small pieces like this to find all those individual letters, values that they're asking you for. It makes it a little bit simpler than trying to like do it all in one big step. So I'm going to take 28.3, that goes in for P, 9, that goes in for H, and then 63.6, that goes in for that capital B. So 28.3 times the height, 9, plus 2 times 63.6. That's the sentence that I'm looking at here. So I'm going to go ahead and type this in. So we get 381.9 if I round it there. That's what it comes out to be on my calculator. And so then I would label this centimeters squared. Do you guys have questions on how I got those little pieces? Okay, let's do the next one here. So total surface area of the prism. We're going to use that exact same formula that we were just using on that cylinder. So I'm going to go ahead and do what we did last time, break this apart into those small pieces. So let's start with finding perimeter of the base. What shape is the base on this prism? The triangles. Okay, how do we find perimeter of a triangle? That's area of a triangle. How would you find perimeter of any shape? Add up all the sides. So what are the side lengths of my triangle? 3, 3, and 3. That 2.6 is referring to the height of the triangle. So I'm going to add 3 plus 3 plus 3 here, which is going to be 9. So the perimeter around that triangle is 9 centimeters. What's the height of this prism? 15. Now for capital B, that's when we want to use 1/2 times base times height. So the base, and we're talking about just the triangle shape. The base is 3, and the height I said was at 2.6. So 1/2 times 3 times 2.6 is going to be 3.9. Okay, so now we have these 3 pieces that we need to plug in, the 9, the 15, and that 3.9. So we're going to take 9 times 15 plus 2 times 3.9. So type that in your calculator, and you should get 142.8. And we're back in area, like I said, so centimeters is going to be squared. All right, on the next page, number 4 says to find the surface area of a sphere that has a diameter of 90 centimeters. So spheres, like we talked about, only has total surface area. There isn't lateral and total. So we're going to use that one equation that I gave you guys, which said 4 times pi times r squared. Now this says that the diameter is 90 centimeters, so what's the radius? .45. So let's take 90, divide by 2, so we get 45 centimeters. So that's what's going to go in for r. So you're going to take 4 times pi times 45 squared. Okay, someone out there, I want you guys to calculate that and then tell me what you get. You're going to get a big number. $25,000 for what? 446? I'm getting 25,446.9 centimeters squared. Okay, last one. This one wants us to find both lateral and total surface area of a cone. It says that this cone has a diameter of 8 centimeters, height of 6 centimeters, and a slant height of 7 centimeters. We talked a little bit about the slant height yesterday because I told you guys that cones and pyramids both kind of go down at an angle because they have like that vertex top point and then they go down at a side. So that's the slant height that they're referring to. You have to use slant height when you're talking about surface area. You don't use it for volume. Volume you use like the perpendicular height inside of the shape. So for a cone, if we go back onto that formula sheet, your lateral surface area is pi r s. S is that slant height that I was talking about. And then total surface area is pi r s plus pi r squared. Really quick, I'm going to come back up to your guys' chart for a second here. I want you to take a look at the equations. Like, take a look at your lateral surface area and your total surface area for all of, like, for these two. Do you guys notice anything about the total surface area in regards to the lateral surface area? Do you see how this says pi r s? And right underneath it says pi r s plus pi r squared. So when you're finding total surface area, you're actually using lateral surface area and then just adding in the area of the bases. Because that's like the difference there. So when I'm looking at this cone, when I find pi rs for my lateral surface area, I can just use that number that I find and replace the pi rs in the total surface area. I don't have to go back and recalculate it. So you can kind of save yourself a little bit of time calculating wise. You don't have to type it all back in your calculator. Okay, so this says that we have a diameter of 8 centimeters, height of 6, and a slant height of 7. For lateral surface area, I need to do pi rs. So pi times, what's going to be the radius for this problem? Four, because the diameter is 8, so you want to divide that by 2 to get your radius, which is 4. And s is your slant height, so which height number do I need to use? Because they give me 2 in this problem. 7. They're probably giving you the 6 to try to trick you and make you think that you need to use that one. So at this point, that height number, that 6, is useless information for this problem, unless they had asked me to find volume. Then I would need that number. So I'm going to take pi times 4 times 7. I get 87.96. Okay, if you wanted to round it up to 88, you could, because that 9 would have to round up because it's followed by a 6. So because I found this, so this would be centimeters squared, that's one answer. I'm going to use that now, though, to help me find the total surface area. So I'm not going to do pi r squared again. I already did that one time, so I'm just going to put this 89.76 in for that. And I'm going to add pi times radius squared, which you guys said the radius is 4. So I'm going to do pi 4 squared. Whoops, I wrote that number wrong. 87.96. Okay, so 87.96 plus pi times 4 squared, or times 16, is going to give me 138.2. And it says round to hundredths, so I'll go out one more, 3, and that would be centimeters squared.